So hi, my name is Joseph Monty, and this is part 2 of my video. This is on the Geologic map, and steps taken to create it. So let's get started. Here is my picture of my Geologic map that is of the Blacksburg Newport area. Let me turn off some layers real quick so we can get a better view of what we see here. Devonian cross-section, Mississippi. Cool. I'm going to zoom in here real quick. Bear with me. So, what I have left on is my strikes and dips and the basic map. This map is an image from Google Earth. It is not dynamic. This is the only thing that is not dynamic of my model. The strikes and dips will, however, go to their coordinates that are dynamic. If Google Earth changes for some reason, let's say we had a major earthquake and part of Virginia fell in the ocean, the points would match up where I put them. Hopefully, I'm not sure really how to test this, but it's worked past in other mining applications when things have changed. So this is the basic map that we're given. Dr. Law's is slightly more rectangular than mine. Mine is more squarish, I guess you would say. And I have various strikes and dips along regions. So we have 460 running. So let me turn on some layers, see what I did here, so we can get a better picture. So the limestone, Mississippian shale, Devonian, Silurian, where'd you go? What division? Moccasin. Cool. So here's my basic fun colors. Each of these layers are hatched, so we can get a better picture. We have, I forgot to turn on my thrusts. Let me do that real quick. Pulaski and Saltville. Each of these are hatched, so you get a better picture. They're not hatched in my cross section, but we'll talk about that later. So we get the basic picture. The cool thing about Google Earth and the USGS is I was able to check this. So if I turn off the outline in the background of my map, turn that off real quick, and I'm going to turn on the USGS units. So this is a really great way to check my work. We're slightly different. We have the Pulaski thrust running down that valley by North Main. So ours is slightly different mapped wise. This boundary looks great. The Silurian layer is slightly different with the Devonian. I'm sorry, I said it backwards. Silurian, Devonian. But the layers look pretty good relative. The USGS probably didn't go into as much detail as we did, and we were looking at different outcrops. They had a larger area to interpolate data from. So I'm pretty happy, pretty confident in our measurements. So I'm going to turn that off and go back to my outline. This is the basic map, so I'll be talking more about my cross-section in a second. So let's go to the cross-section.